right, good morning. Now, good news is that 90% or more of what we're about to look at is the exact same thing we did last week. So it's more practice for that for the most part, with one little step added to the end. And what that is, what we're looking at is called percent yield. Now, percent yield is looking at what we think we should get from a reaction versus what we actually get. And the two words we're going to throw around a lot are actual and theoretical. Anytime you hear the word actual, that means in reality, in the lab, what is there in the beaker. Theoretical is what we calculate. So when we do all that stoichiometry calculations we were doing last week, notice in those calculations, there wasn't my lab partner spilled it as a step, or some of it didn't react, or, my lab partner has a drooling problem, and yeah, you get the idea. All of that real world stuff that happens, losing some of the material, some of it not reacting, some, anything, that's not in the numbers. When you calculate what you should get, that is assuming you get 100% of what you should get. What we want to do now is do the math like we were doing, see how much we should get, compare that to what we actually get. Now, you say, okay, I've got it. Well, the reason I'm hammering this so hard is because this is the part that gives most people the trouble, is because most people don't like to think about their numbers. When you read a problem, they're going to have to give you the actual yield. And you need to pay attention to what that is. Because the only other way is we'd have to go back in the lab and measure it ourselves. But you need to pay attention and identify, okay, that's the actual yield. I need to put that aside until the end. Most people look at it and then they try to throw it into the calculations. It's like, no, think about the numbers. So the actual is the lab value. The theoretical is what we calculate. So here's our example, and this is the super short one. A 1.75 gram sample of C7H6O3 is reacted with excess methanol to produce C8H8O3 and water. In the lab, 1.42 grams of the C8H8O3 is actually isolated. What is the percent yield? Well, we need to compare apples to apples. So we have the actual yield of the C8H8O3. I need to figure out, well, how much should I have? For that, we're going to need to do the calculation. Now, this calculation is exactly what we were doing last week. If you need a little practice, pause, work it out, we'll go through it. Okay, so here we go. First thing we need, balanced chemical equation. Bam. Okay, excess methanol, you might have had to look up methanol, CH3OH. So after we do that, we find the moles of what we're given. We're given 1.75 grams of C7H6O3. We need to convert that to moles. Okay, that's step one. Find the moles of what you want. So our BCA table at the beginning, we have 0.0127 moles of the C7H6O3. We have excess of the methanol, it doesn't matter, 0 and 0. So we're going to use all of that up to get 0. The methanol still doesn't matter. So it's a 1-to-1 ratio, so we're going to get one of those. Now, with this, you need to stay focused in on what it is we're after. We know our actual amount of this, we need our theoretical amount of this, which means the water doesn't matter to me. It doesn't ask me anything about water. So this is the number I'm after. Once I have the moles of what I want, I convert that to grams. So classic mass-mass stoichiometry. Start with mass, convert it to moles. Convert moles of what you have to moles of what you want. Then convert that into the mass. Now, step 5, finally, the first new thing, so we calculate the percent yield. Our theoretical yield, our calculated yield, was 1.93 grams. What we really get is 1.42 grams. So actual over theoretical times 100%, 73.6%. So out of what we think we should get, we got a percent yield of 73.6%. Now you ask, okay, is that good? It depends. There are some reactions that if you put it together and you don't get a 95% yield, you really screwed up. There are other reactions that, you know, if you get a 10% yield, if you can actually get 10% of it to react and collect it, you are doing great. So this is just sort of a way to compare.